Hello and welcome. Today we're diving into how to design a parametric bunker tailored for grain and solid handling, all within Autodesk Revit. First, we need to create a couple of reference planes, 4 for the top face and 4 for the bottom face of the bunker. Then we need to add dimensions to it, equalize them and assign the labels to the dimensions. But we will postpone labeling for a bit. Geometry we will create using sweep instrument. Let's start from the path, and the surfaces of the sweep will be based on the profile family. We've been creating similar kind of profile before, and you can check this out for more details. Okay, let's create a rectangular shape, and we also need to indicate the outline for the thickness of the item. Do not forget that the item should be enclosed, but do not create it with two different shapes. Now let's add a couple of additional reference planes to add a dimensioning and to add labeling to the dimensions. Do not forget to ensure that the labeling will be assigned to the category of type. Now we can save it and load it back to our initial family. Next we need to duplicate the inserted profile type, because we're gonna use different type of the profile for the top surface and for the bottom surface. And then we need to assign proper labeling to it to ensure that the geometry will appear in the correct way. The next step will be to assign the proper profile to the corresponding face. Once that's done, let's check it out. Let's modify the value of the dimensions and see how it was changed. Here we can see that the gap is a bit too big and we need to jump into the profile editor and adjust it slightly. Ensure that the gap is not too small, otherwise the profile will not work. Then let's add a couple of nozzles, giving them a slight update. Afterwards, let's align them and ensure that they are located in the proper position. Now let's set additional reference planes to indicate the height of the bunker. Now we will jump to the next stage and we will create the flanges for the bottom and the top face of the bunker. Let's add a couple of reference planes to indicate the outline of the bunker. And then add a couple of dimensions to it, equalize it, so afterwards we can give it a label. It's time to add the shape of the flange. For that we will use instrument of extrude, and we will indicate the inner line that will match with the reference planes and the outer line of the flange that will indicate the thickness of the flange itself. I mean the width of the flange itself. Next step will be to indicate the thickness of the flange. We will do it simply add an additional parameter to the extrusion property. Let's adjust geometry for a bit. Once we are done with the main shape, let's create a hole for a bolt. For that we will use the void form and extrusion function. Let's draw a circle and set the diameter of the bolt and the height of the extrusion to match the thickness of the flange. Then we will indicate the axis of the hole and add a couple of dimensions to log displacement. Next, we will create a vertical array with 6 items and define the distance between the holes. Then we will add a label to the count of the holes. First, we will create the label as a set parameter that we will use in the future expressions. And then we will create a label that we will use as the expression. After that, we'll repeat the same steps for the horizontal array. Now it is time to set the expressions that will help us to define the behavior of the holes, distance and Kelvin. The input for that behavior will be the initial amount of the holes in the vertical and horizontal arrays. Then let's repeat the same exercise in the top right corner, using the same item as an input for the array. Now let's load family back and assign it to the surfaces. Now let's jump back to the family and adjust the behavior of the reference planes. We need to change it to not a reference to ensure that we will not be able to modify the geometry of the object within the family by intentional touching the anchor point. Let's position the flange and align it with the center line of the family. As the family becomes more and more complicated, my advice would be to save the body of the bunker as a separate family and create another family that will work as a host, where we can combine all the parts together. Now that we have created the host family, let's load all remaining families in. Then we need to create a reference plane that will indicate the height of the bunker, but also will be the basement for the top flange of the bunker. In cases when you are dealing with the complicated families like that, to avoid the data inconsistency, the best practice is to use shared parameters that will allow us to use the same kind of parameters everywhere. Now that we are mostly done with the shared parameters, it is time to assign the parameters to the family properties. And once we are done with it, let's add a couple of remaining items such as nozzles for the instrument connections. As the final step in today's video, we will model the soil for the bunker. Why do we need it? It will help us to define the effective volume of the bunker based on the current geometry of the bunker and the properties of the medium. We will start from the metric generic model. We will start with a family based on the metric generic model, adding a reference plane to indicate the height of the bunker, that in the end will be the top level of the medium in the bunker. Next, we need to add reference planes that will indicate the geometry of the bunker and match its outline. Then, we need to add dimensions to it and assign labels to the dimensions. Once it is ready, we can create the main geometry with the swept blend tool. Finally, we need to add the void form with the reference plane that will allow us to control the angle of repose, which will ultimately define the final volume of the bunker. Once we are ready with the geometry, let's define the material appearance that should match the crane. For that, we need to create the new material and use the picture as a basement for it. I've downloaded already the picture in advance and we will use it as a basis for the family appearance. We need to click here, then I need to define the picture. Yes, and this picture we will use as a basement for the material appearance. I will call it crane. We need just to click on apply, and that's it. As you see, now this cone looks like a pile of crane. And we just need to load it back to our bunker template. Let's go to the plane view and insert. The final step will be to match the properties. Yes, we just need to link it with the properties within the family. So bolt L, bot L, bot W, bunker medium angle, bunker medium height, I'm not sure, level. So bunker medium level will match with the height of the bunker. And top L and top W. And that's it. Now once we change the appearance to realistic, hard to see here, but once we will load it to the family, you can see how it looks like. Yeah, so it is barely crane. And yeah, that's it. Please like this video if you enjoyed it, and thank you for watching, and see you next time.